Okay, grade 6, 7s. We are looking at your homework for the week, which is to calculate the perimeter and area of a whole bunch of shapes on your garden. So the first thing that I want you to look at is, where is it here? There it is. So this was my ultra lame 40-year-old guy additions to our food forest and to our extension that we have. So as you can see, I've got all my shapes laid out. Pretty straightforward. Some of my colors aren't very clear because this has been scanned, but this is a picnic area, and another picnic area over here. So what we're going to do is we're going to start looking for shapes. The big thing with shapes is that what you want to look for are the rectangles and squares that we're dealing with. So for example, you can see that if I shrink this down, I have a square there. It's the same square that I have over there. If we look on this one, if I shrink this down a little bit, there we go. Actually, let's get this so it's hollow. See right there, I've got a 2 by 2 square, which is also up here, down here, down here. We've got a whole bunch of them up here. There's another one up here. Is there any over here? There's almost one there, but not quite. Then I have these little squares. These are little individual squares. I even have a rectangle over here. That's going to go whoop. It's a 3 by 1 rectangle. Oh, yeah, you see that other one there? Good. I know you can see them. We can break all of these things up. So squares and rectangles. I want you to find unique rectangles, and I'm going to ask you for homework to find 6 unique squares or rectangles. So I have another working document here that we're going to be using. So on this one, I've identified a whole bunch, and you've noticed that I'd labeled it here. So whenever you're dealing with squares, you're going to number them. This is square 1. If I wanted to make another square, I could do one of these little 1 by 1s, probably the easiest right there, 1 by 1. I'm just going to color it for the purposes of this little task. So with that, I have another one. So this one here would be square 2. If it's a little too big, just make it a little smaller. There we go. Square 2. So you see how I have that square? I could also move that one to this. Any other individual squares? Yeah, right here, right here. So you're going to label all of the similar or congruent shapes that you have on your page. So the math. Now we worked on this a lot in class. So if you didn't get a chance to get to it, and you didn't come and ask for help, like I asked everyone to, this will guide you through the process. We are dealing with 2 primary formulas. The first one is the area of a rectangle and the perimeter of a rectangle. So length and width, L and W. Let's go to square 1. Remember, the big point here is that I want you to label these on your map and then have the corresponding number or letter on your sheet. This is going to be done on a separate piece of paper. I am looking to see how clearly you can communicate this notion that this area and perimeter shows up over here, so I can reference the 2. So the first one we're going to look at is actually let's do perimeter first. How I had this set up is ideally how you'll set up your sheet. So you'll have the area and the perimeter right next to each other. Because I'm using a computer for this, it's not going to work quite so easily, but that's the general layout that I'd like to see. Okay, so let me just cut this, paste it down here. Okay, so let's start. Perimeter. Now really, what is perimeter? Perimeter is primarily the distance around a shape. So let's take a look at the square 1. I have 1, 2. See that measurement? The line, every line we're going to call 1 centimeter. So I have 1, 2 centimeters up and 1, 2 centimeters over. I could easily just go 1, 2, 3, 4, 5, 6. There's 8 centimeters that go around this. But the whole process of this is for you to get used to using 2L plus 2W. Because believe it or not, in a little time, by grade 7 and 8, it's not as easy. Now we had talked about these being terms. So anytime you have a number attached to a letter, this is called a term. And these terms are neat because one of the big tricks I gave everyone in class yesterday was when you have a term, when you fill in the numbers now, put it in brackets. So I have 2 times my length. Now, the length of square 1 is 1, 2. 2 times 2. Now, I plus it with my next term, which is 2 times, well, that's 2 as well. What do you notice about that? With a square, because all the sides are the same length, you can actually just do 4 times. Here's the alternative. You can do 4 times the length, 4L. Okay, so an area of a square, perimeter, hope you got that, of a square could also be written as 4 times L. I'd like you to do this because now we have order of ops. I have to do my brackets first. 2 times 2 is 4, plus 4, and that's going to equal 8. Now, these are centimeters. Are they centimeters squared? No, because they're distances. Remember, if I walk and walk, I can't walk in a square centimeter. So the perimeter is the distance around. Now let's look at the area. So you're going to do that for all of the shapes you identify, the rectangles and the squares. So notice here how this square 1, I've also labeled as we go around. I'm not going to do it all. This is just for demonstration. So I should be able to see really quickly that S1, this is the area. Or the perimeter. Area. Area is a little easier. So we're still going to do length times width. In my square down here, I have 2 by 2. So this is going to equal, the length is 2 centimeters. I'm going to times that by 2 centimeters. Well, 2 times 2 is, that's right, 4 centimeters. But this is where we have to add a lovely little, just like one moment, text, font, baseline, superscript, squared. The reason we have to add that squared is because we are now measuring how many individual little centimeter by centimeter squares is in that. Centimeter times centimeter gives us centimeter squared. That's the big difference between a distance and an area, is the unit measure. So perimeter is a distance. We are measuring that one in centimeters. Area, see, we're just adding centimeters by centimeters. If you add centimeters to centimeters, you get more centimeters, just like apples. You add apples to apples, you get more apples. If you multiply centimeter by centimeter, you're left with centimeters squared. Okay? And that's one of the things they'll be really looking for. Now, so there's a whole bunch of squares I could do there. Next thing we're going to take a look at is the area of a rectangle. So let's take this area of rectangle 1. I've highlighted it here, so it's 1, 2, 3, 4 by 1. So the length of this is going to be 4 centimeters. Centimeters. My width is going to equal 1 centimeter. First thing we're going to start with is the perimeter. Hey, come on now. Cut. There we go. Centimeter. Okay, let's paste this down here. So remember, I'd like these side by side. So my perimeter, what's the formula for perimeter of rectangle 1? Look up top. All your formulas are here. Say it. 2 times the length plus 2 times the width. Remember, you could just add it up. 4 plus 1 is 5, plus 4 is 9, plus 1 is 10. That's easy. I know you can do that. We're working on putting the brackets around the term. 2 times length is 4. You can even add your centimeters in there if you want to get practice at doing it how we do it way up at the grade 9 level, 8 and 9 level. 2 times 1 centimeter. Not xm, cm. There we go. I move through with my mathematical rationale. Order of ops. What do I do first? Bed mass, brackets. 2 times 4 is going to give me 8 centimeters. Plus 2 times 1 gives me 2 centimeters. I finish up. Do you guys see what I did wrong there? I was doing that under the wrong formula, which won't work. There we go. Now I have 8 plus 2. That's 10 centimeters. Is it going to be squared? No, because this is a distance I walk around. Next one, area is length times width. So this one, my length is going to be 4 centimeters times 1 centimeter. I'm multiplying centimeters by centimeters. 4 times 1 is 4. I now get 4 centimeters. Save some time. Paste. 4 centimeters squared. Now count it. Here, let's move this out of the way. The nice thing about this is you can check it. I have 1 square. I have 2 squares, 3 squares, 4 squares. That's the right answer. 4 square centimeters. 10 centimeters around. You can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the right answers. I've got it. So that's the basic structure on how you're going to do your squares and rectangles. All right. So you can see here I've identified a second rectangle, a second square. Make sure you have 6. I could even do this gigantic long one up here. This would be a fun one. That's a gigantic rectangle right there. Next thing I'm going to talk about is the area of your triangles. Now, we didn't talk about this because only a few people asked the question. And the big thing about this unit is that when I give you time in class to work, I need you to work on it so we can get through this stuff in a way that actually means something to you. So when we take a triangle, it's really important that you're taking half, or you take the base times the height, divide it by 2. Thank you, Mr. Alex, for that ingenious engineering. You have no idea what's happening on this side of the mic. Okay, so what we're going to do is let's identify a triangle here. So, Mr. Alex is making it really hard for me to do this. Okay, so I have this big triangle at the bottom. So I'm going to just draw this triangle shape like so. Like there. There, we got a triangle. Perfect. So the formula for a triangle is 1/2 on the right-hand side, base times height. Another way to think about that, though, is base times the height, which is what? Same as length times width, identical to a square. And we divide that by 2, just like we talked about in school, in class. So if I take this square and I draw a line through the middle of it, the area of the triangle is just going to be half of the area of the square. So the big thing here, though, is as you can see in this picture, we don't want to take the slope of this. If we measured from here to here, that wouldn't give us an accurate description. So we actually want to take the height from the point all the way down to the bottom. So that line is going to be our height. Make it a little bigger here. Okay, just like in this diagram over here. And this you can actually calculate. So we have a 90-degree angle at the bottom. So let's take a look at this. So my area of triangle, grab this here, copy, area, let's call this T1 for triangle, is going to equal, it's going to equal base times height. Now in computer language, the backslash means divided by 2. Okay, so let's calculate it. What is my base? Well, if you can see here, I have 1, 2, 3, 4, 5 rectangles are underneath here. So from this corner to this corner, I have 1, 2, 3, 4, 5. My base is going to be 5 centimeters times the height. Now, the nice thing about this paper is you can just add up the squares. So from the bottom to the top, I get 1, 2, 3 is 3 centimeters. Now I divide that by 2. Now guys, we're right back to our very first unit of order of ops. What is 5 times 3? It's 15 centimeters. Now is it going to be centimeters or centimeters squared? What is it that we're actually calculating? Area, so it has to be centimeters squared, and we divide that, copy, divide that by 2. Now this is where, if you're not sure how to do parts or decimals, grab a calculator. But I'll tell you, I know 8 plus 8 is 16, 7 plus 7 is 14, so the answer is going to be 7.5 centimeters squared. Copy, paste. All right, you're going to do that for at least 2 triangles. Now some of them you don't have to do this fancy little line through, because what happens is that we end up having, oh, that's not even drawn. Here we go. Will you draw for me? Draw for me. We go from here to here to here. See that triangle? Oh, it's not quite right. Let's try that one more time. See if I can get that 90-degree angle perfect. There we go. Hopefully that'll, whoa. There we go. So in this one here, do you see how I have a 90-degree angle? Well, this one here, this is going to be my base. It's going to be 2. The height is going to be 1, 2, 3. Don't have to draw the line on that one. All right? So that's how you do the area of a triangle. I'm going to ask you not to do the perimeter because it may look easy, but there's a fancy formula we have to use called Pythagorean theorem. If you want to go for it, I've got videos for the grade 7s. You can take a look, but please let me walk you through it next week. Thank you everybody for watching. This is the one on triangles and what are those? Rectangles. Make sure you have really clear mathematical rationale. That's what I'm looking for. See you next week.